Hey everyone, welcome back. I hope you are doing awesome. So imagine you are searching for your friend's contact in your phone without an index, or I would say without an alphabetical index or the search. So what would you do? You would like scroll endlessly. Okay. So like databases face the same problem. So that's why we use indexes. What it does, they make like your scanning fast. So yeah, in this video we'll break down like what indexes are, how they work, and like the different types of indexes. Like you have heard about the clustered, non-clustered, but there are special like your B trees, how that works, and your hash and geospatial indexes. So yeah, in this video we'll cover these all. This would be a high level video of all those. So without any further ado, let's start with the video. I'll see you there. Hey, what's up guys? Hello. I hope my screen is visible. Cool. So imagine for a contact in your phone book without an alphabetical index, you would scroll forever because you are not finding, you have no feature of like alphabetical index. So databases faces the same problem without indexing. Okay. So database indexing, what is an index? So database indexes are just like you have index at the back of the book. So you do not need to go to the each page and search or scan. You just go to the index and look for that particular keyword and you can directly move to that page. Same your database indexes work. You do not need to like scan the entire your data or the rows. You just go to the particular page or the document, you just fetch the data. So like a database index is a special data structure that improves the speed of data retrieval operations on a database table. Cool. So like how does a database actually store table rows internally? So like as we all know, like it stores in the form of table, row and columns, but like they store them in pages or blocks we can say, and usually those are your fixed size blocks, could be your 4 KB, 8 KB or 16, but that depends on DB, it could be vary. Okay, so it inside like table internally it stores in your block and pages. Okay, so like how does a database engine locate a specific row in a table without using an index? So suppose when you do not have any index, so how it will locate your database engine? So I have one like a small example I would say. सॉरी गले में थोड़ा ना मतलब दर्द हो रहा है. Okay, so suppose you are making a query to the database, and suppose this is your memory RAM, and suppose how it will go, it will like from the database it will pull the page 1 into the main memory and check. If it founds, then well and good. Not, then it will go fetch the another page. Same way you can see here, pull a page into memory and search for the row, pull another page into memory and search for the row, repeat until row is found. So this is called your full table scan, and it takes of n time complexity. So this is not the good way. So indexes helps us here, like how. So let me show you here. I hope it's readable. So like once data is stored, what different type of indexes can use to speed up retrieval? We know what is indexes, as I told you in the previous slide. So we know how data is stored. So once the data is stored, what different type of indexing can be used to speed up the retrieval? Okay. So you may heard about the clustered, non-clustered, might be unique, composite, or specialized, but this is the coolest, like your specialized, and I would say in the upcoming geospatial index. Okay, so let's go one by one. So clustered index data is stored in the order of index, It's like basically cluster index determines your physical order of the data, and your non-clustered you can say the logical order of the data. So what happened, like we store data like in a sorted manner inside clustered. Like everybody knows, like clustered we can create only one index on a table, non-clustered we can create multiple. So if we already, like we said when we create the table, so on the primary key it's by default the clustered index. Yeah, you can delete that and you can create your own clustered index new one, but you have to delete the earlier one which was created at the time of table creation. Cool. So this is in the sorted order. So this is in the sorted order. Okay. And so here what we do, we directly map the indexing, but here inside non-clustered we just keep the different table or the structure where we are just pointing the memory location, and from where you have to keep to the actual memory or the actual data. Or like clustered, non-clustered you can read from, I'll attach one article so you can read from there. It's a basic one, everybody knows. Okay. So next we have unique index. Unique is like the email, you want to be like email must be unique. So that is your unique index. Then composite, when we have like multiple columns and we are combining them, so that we can say the composite. Then come specialized index. This is the coolest, I would say. So inside specialized we have hash, bitmap, geospatial, inverted. Okay, so behind these indexes, like what data structures are used and how do they make up lookup faster. Okay, so we'll cover your B trees, hash table, or bitmap, or inverted. Cool. Do I have? Yeah, we have B trees. Okay. So B trees we can say it's like the default one, default index in your most of the RDBMS like your SQL, Postgres, and your SQL Server. So this is nothing like B tree is your balance tree data structure that, yeah, that we have inside or we have studied in our data structures and algorithms. Okay, so where your all leaf nodes are at the same level that you can read from probably on the B trees. So what it does, it basically allows your algorithm to look up in the log of n time logarithmic. Like we all says, like indexes work behind the scene on the B trees. It implements your binary search, that's your log n, and these are perfect for the queries like whenever you have like in the range between greater than equal to those all. So let me show you how it works. So suppose these are the this is the root and these are our like the, I would say, the pages or the blocks. So how it goes, like you got a query, select star from users where age is equal to 51. So it will first bring this into the memory block. Just consider this root as a one page. So it will check 51 is here where the 50 or 90 is pointing to the next node. It will go here, and let me use the laser here. It will go here and it will see like 51 is less than 55, so it will see like page 3 is like it is pointing to page 3, so it will directly use your page 3 and pull that into your main memory and it will return the data. Okay, so now you may have a question like what if I have here greater than. So again it will start 50 greater than, it will go here and it will see like 50 to 90 we have this range, so it will like pull all these like your 5 or like whatever pages they are. I suppose it may have the further pages linked to that, so it will pull all those pages inside your main memory and return them, because we have to return all the greater than 51. So that's your range query. So B trees are the like the default one, like when we create index, so this is the default one when you searching for a range data. Okay, so next we have the hash index. Yeah, so hash index is, we can say like this is it maintains your one hash map. So let's read what is written here. So key, there is a one hash function, you pass the key or it will create the hash for that, and correspond to that hash it will create the dedicated page wherever the data is located stored, so it will locate directly from there. So like it is best for your exact match lookups. Yeah, whenever you are looking for a particular key, and it is best for that. It is not best for your range queries, like as you are like where age is between 20 and 30. It is not good for that. It is for best like the Redis using this hashing. Redis use this, like inside Redis you store your like key value pairs data, like this is my key and correspond to that, this is the value. So like here suppose I have this email and there's a hash function who is generating the hash for that. And how the hash works, this is the diagram. So here you can see email and this is our hash function bucket. So it is just storing in the hash map. I believe you all know the working of hash map. In this video we should not cover like how hash map works. Okay, so very good thing, it provides your of one lookup. It's fast. Okay, so now next we have your geospatial index. Okay, so have you wondered when you write a query like suppose I need to find all the restaurants within 5 kilometers or nearby me within the 2 kilometers or something like that. So there your special geospatial index comes into the picture. Sorry. Okay, so like let's read here, specifically designed for location based queries like finding place within a radius, nearest neighbors or points inside a polygon. Okay, so suppose like when you write a query like select star from locations where latitude is this and longitude is this and this and this. So how it is done normally. So first suppose you will mark your this latitude, you will find this, then you will find this, and then you will merge all those operations, and this is the merged area that you have to return. You have to return the intersection of this, and this is like the costly operation if we talk about the database side. Okay, so for that we have like particular, like I would say, the algorithm or the types of geospatial indexes. So like first understand like what are the like your real world uses of that. So like your Google Maps, Uber, Zomato, like find nearest drivers or the restaurants, for those we use geospatial indexes. And your PostGIS, it's inside your PostgreSQL extension, which basically use your advanced geospatial queries. Okay, and if we talk about your MongoDB, so for that it has 2D sphere. For that it has your 2D sphere and 2D indexes. And for Redis, it's provide your GeoAdd, GeoRadius, GeoSearch, which like using the Geohash you are under the hood. I'll tell you like what is Geohash. Okay, so let's move to the types. Ha ha ha, here you go. So okay, it's readable. Okay, so the types when we talk about, so we have the very first is our Geohash. So while like how it works, it basically encodes your latitude and longitude into short alphanumeric strings. And like as I mentioned, like we looking for the nearby locations, but it worked on the prefix. So like nearby locations share similar prefix, good for prefix search. How it works, suppose you have like Delhi, Gurgaon, Noida, and they all shares the same prefix. I have one example of this as well. No, where I have missed that. Let me quickly open that, just give me a sec. So as you can see here, this is your geohashing visualization. So as I was saying, it works on your prefix. It basically creates the so what it does, it basically creates the hash, and like all the prefix it has, it returns based on that. So suppose for like see for your Delhi, Gurgaon, Noida, Faridabad, they all share the same prefix T1V7. Okay, so like when we are finding like those all like restaurants in the areas, just the surrounding. Okay, so for those, these are the perfect. So let me show you, like if I am just here, so these all prefix come under this. So this is recursively expanding into your layers. So now suppose here we have for the 0 we have all the possibilities for 0, for the like 1 we have all those, for b0 we have all this. So on the basis of this, so later on it will create like all your nested. So have you ever like zoomed into your Google Maps or something? As you zoom in you find all the like sub areas or the nearby areas of that. So inside that they are using your geohash. Okay, so like geohash encodes latitude and longitude coordinates into short alphanumeric strings, and nearby location shares similar prefix, making it excellent for like your proximity search and special indexing. Okay, so this was for this. So let's move back to our, where were we? So that was about your geohash, and like it is nowadays using, like this is the, I would say the popular one, geohashing. And like your Redis uses this your geohashing, and like nowadays inside production databases we are using geohashing. Okay, so next we have the quad tree. So quad tree, what it does, so let me quickly show you. We have one this example image of quad tree as well. So it's saying divide space into 4 quadrants recursively. So suppose this is our one root and this is the root. It divides into 4 quadrants. So your tree has 4 children. So 1, 2, 3, 4. Just ignore the nested quadrants. So it works on the like k values. So if we have the k value greater than 5, then split. So as you notice here, we'll have the dot, and suppose these all are businesses. So here we have less than 5, less than 5, less than 5. But inside this quadrant we have the greater than 5. So suppose this is the one, your child. So we'll again divide this space into 4 quadrants recursively. So again it has been divided, where we have 3 here, 4 here, 3 here. Again we have 4 nested quadrants. So for this one, this was our parent and these all are the leaves. For like this one, we again are dividing into the 4 quadrants until our k value is greater than 5, or until our k values or like the businesses becomes less than 5. So again, if suppose here we have the greater than 5, then again we'll split them into the 4, nested 4. So like this way it works, and this is efficient for your hierarchical partitioning of geographical areas like maps. As I was like nestedly it is dividing. So this was like the foundational, I would say the quad tree was the foundational index for, or the algorithm for your geospatial indexes. But nowadays we use your geohash, not this. Okay, so next we have the R tree, which is your rectangle tree. So this is like specialized tree structure for multidimensional data, and groups your nearby objects and represent them with the minimum bounding rectangles. And this is commonly used for special queries like find all restaurants within 5 kilometers of me, or which bus stops are inside this city boundary. So how it works, so let me show you here. So we have one more example, not this is the like for your R tree. So as you can see here, let me expand this. Cool. So suppose this is your R tree where you have 2 root nodes. As you can see, like this n is the bounding and this m is the one rectangle. Inside that you have 1, like this is your j and this is your k inside n. And as you can see, like we have nested and we are just making the boundary rectangles like within the areas. So like this is, or you can say like this is just making the clusters, and again we have tree, and this is also like R tree is derived from your quad tree. And also like for the R tree, like in PostgreSQL we have PostGIS extension which uses your R tree. Okay, so the next we have the inverted index. So like an inverted index, you can say like when you have to search for the as you can see, select start from document where name is like index, could be a pizza. So how it works, suppose it works when suppose you have particular, it basically creates the hash map. Suppose you have these documents, your database index improves, so this is document 1, this is document 2, this is document 3, and suppose these are your data. So how it works, it basically creates takes all the keys, and then whatever, like the whatever keys in whosoever in the document, it just take, so it will create like the hash map of your tokens, or I would say the keys, and in the values it will store like in which pages I found these your keys. So as databases I found in doc1, indexes doc1, doc2, doc3. So like when you will search this, like select start from document where name like your index, then it will simply return doc1, doc2, doc3. In these pages I found these. So this is for your inverted index. Okay, so like now we have the summary. If I talk about like B trees, when you should go with the B trees, when you have the general queries. Okay, like when you're searching for age ranges, like age is greater than this, and like could be any other thing, like salary I can say. And next we have hash indexes when you are looking for exit lookups, like you found in the cache, like Redis you use your hashes. And when you have geospatial, when you have like maps and location, you are working with longitude, latitude, all those, then you have to go with your geospatial. And the last we have inverted, when you are just searching for the text inside the documents or the data, then you may go with your inverted index. Cool. So this was the summary of this. Have I missed anything? So yeah, I had prepared one thing. Let me quickly. That was on whimsical. So I have prepared like this flowchart, I would say. So might be it would be helpful. So like how to decide or choose like which index I have to go with, or either I have to go with the index or not. So like need efficient data access. If no, then go for the full table scan. If yes, then check if your table size is greater than 10k rows. If no, go for full table scan. If yes, then what type of data are you querying? Yes, it depends on what type of data are you querying. So suppose you are like full text search. We heard that for the full text search we use inverted index. And if you are looking for location data like your maps and locations, for that you have to use geospatial index. And everything else like the range queries and all those, you may go with the B trees. So this is the like high level, or I would say the cheat sheet or the flow chart, which would help you to like quickly recognize like for which type of index I have to go with. And again that will depend on which type of data you are querying. That again depends on scenario. So yeah, I believe we have pretty much done with the video. Yeah, that's all for this video. I hope you found this video helpful or useful. If so, don't forget to like, subscribe or share. I'll see you in the next video.